Hello, my name is Abby. We're going to learn about Git and GitLab today. So basically, what that means, um, so basically what Git is it's a system in which to back up your files. Just like how we use Google Drive or flash drives now, how to back up our files, Git is a more organized version of doing that. And I know it's used in a lot of software fields, but we also can use it here in this way because it can be used to back up any files. So I guess I'll go through this information now. So Git is a service. It's like a way of storing files. Whereas GitHub is the thing that we store the files on. So GitHub and GitLab. GitLab is what we use in SSS to store our files. It is a website that most of you should be having access to, or you all should have access to at some point. If you don't have access, then you would need to go get access to that. But yeah, so GitLab is like the website that hosts a Git a repository. And then I'm going to explain more about what Git is later on. There's a few reasons why we use GitLab. One of the main reasons that we use GitLab is its Git functionality, of course. But there's also project management and documentation fields to GitLab. So there's wikis on GitLab, and there is issue tracking, like epics, if you haven't already been introduced to that yet. So why do we use Git? It's version control. So Git is set up in a way where you can save your work one time and commit that work and say X, and then you can make more changes and you can say Y is done, and you can make more changes and you're like, wait, I messed up all of this work. I need to go back to where X was done. You can do that very easily. It's just literally like one click of a button or like one type into the command line. It backs up your work. It saves everything that you're doing, just like how Google Drive incrementally saves. This is, you have to do it a little bit more manually, but you still incrementally save stuff. And you leave behind commit trails. So one thing in GitLab is commits. So that's just basically saying, hey, I did this bunch of work. And you can look back in the history and say like, oh, like I did this work, Pranav did this work, Sparsh did this work, Michael did this work. And you can see like who did what at what point. So if you have a question about a change, it's easy to go to a person and say, hello, why did you make this change? If it isn't already spelled out in the commit itself. Okay, so here are some quick definitions for Git itself. There's a lot of lingo in Git. So the first is a repository. So a repository is also called a repo sometimes. It holds all of the files from one project. So the equivalent in Google Drive would be like if you had a folder that held all of your files, that would be your repository. We have many repositories in SSS. We have repositories for things like power management and flight computer and engine controller. Each one of these has their own like subfolder within our GitLab of things. A clone is when you get a copy of the repo from GitLab and you put it on your computer. That's very simple. Next, we have a commit. A commit is one like package of changes. So when you do something, let's say you're like modeling something in like modeling the flow of something, and you have your MATLAB script, and you add a new graph to that MATLAB script. You could say for your commit, like I added this new graph, and in that commit, it stores the changes. So it stores, this is what my repository looks like before. This is all the things I've changed to add that new graph to my MATLAB script, and this is what it looks like now. And each commit always has a commit message. So you always say something like added graph to MATLAB script, or changed screw sizes from M5 to M3, or some small little change. That way, the reason why we make commits as small as possible is that if you do need to go back to a previous commit, you know exactly what each commit does, and there's not random things inside of it. So now, kind of stores things, like not all sequentially sometimes. And as you can see in this picture here, you can have different branches. So this is like when you have a state of a repository and two people are making work at the same time. They can commit to their own branches, like above, and then later it'll get combined together, but it doesn't automatically get combined. And so, as you can see from this graph up here, there's this green line is one branch, this blue line is another branch, and this orange line is someone else's branch. So you can have the branch that is on GitLab, the main one is always called master. And so that one, you take your work and you branch off from master to develop in your own safe branch. And once you know your branch works, you can merge it back into master. And a merge is when you combine two branches together to make them the same branch again. So that's when this blue branch comes back into the green branch. And then this next green commit after, or all of these circles are commits. And this next green commit after the blue one merges into the green one, sees both the blue commits and the green commits. And then finally we have push and pull. Pushing is taking data from your computer and giving it to GitLab, and pulling is taking data from GitLab and moving it to your computer. So like I said, there's this one main branch called the master branch. And what we want to do is we want to protect this master branch. We want to make sure the master branch always has something that's working on it and there's nothing broken ever. So the way we do this is we make our own branches, we develop in our own branches, and once we know that our branch is working, we can merge, but each individual member of the club should only ever make a merge request. That's like saying, hey, I want to merge into master, someone please approve it. And the project managers and directors are there to go in and approve merge requests to make sure that this person's work is in fact not broken, and we can merge it into master without making any mistakes. So the proper workflow in Git is you start, you pull from GitLab, make sure you have the most up-to-date stuff. Then you make a new branch and name it appropriately, like I'm gonna add this new graph or something like that. You make the work on that branch, you make that new graph, you make sure it's done, you make a merge request back into master saying like, hey, I made this new graph, please let me merge back in. And then your project manager will review the merge request and merge it into master. Okay, so before we go to the tutorial, I know I gave a lot of information. Are there any questions? No, are there no questions? Can anyone even hear me?
We can hear you.
Okay, cool. I had a small fear that I was just talking into a screen for the past however many minutes. Okay, so now I'm gonna go through of like how you would actually do all this stuff in GitLab. If you have access to the GitLab, then like I would encourage following along. And if you don't have access to the GitLab or you don't want to follow along right now, this presentation will be available at the end, so you can follow along later and like know how to do this stuff in GitLab later. Okay, so the first thing that I'm gonna do is have you install GitHub Desktop. It's an easy graphical interface, and it makes like committing and making a new branch and all this different stuff just a click of one button. I'm gonna like wait like a minute or so to see if you want to like install it to give you a bit of time.
Abby, can you drop the link to the GitHub desktop in the Zoom chat maybe so that
Oh, yeah, that would be helpful.
Do we all have a GitHub account?
You do not need a GitHub account to install the GitHub desktop app. You all need to make a GitLab account. I know it's kind of confusing, but GitLab does not have a desktop interface. Right now, how do I go to chat? Oh, here it is. Okay, and so the only reason why we're using this is because it's nice. There's lots of other graphical desktop things for Git. GitHub Desktop is just a nice and easy one that I chose to use for this presentation. There's things like TurtleGit and like other random ones. If you wanted to use those, it's just this presentation uses GitHub Desktop. Okay, I'm gonna move to the next one. Okay, so the first thing that you need to do in GitLab is clone a repo. So I've made a training repository for you to make, for you to clone, just so everyone is on the same page. So if you go to GitLab and you find this repo called, it's under training, GitLab, and it's called My First Repo, you can clone this repository using this link, this HTTP link. And then in GitHub Desktop, you click on Clone a Repository over the internet, and you paste the link from GitLab into GitHub Desktop. Yeah, and so this basically cloning a repository just takes the repository from GitLab and it makes a copy of it and puts it on your computer. So that way you'll be able to work on your computer and develop stuff on your computer and then push stuff back up to GitLab. Okay, so this next step is I'm just going to talk to you about the GitHub desktop interface after we've cloned the repository. So right now we're in our repository. It tells you which repo you're in. In the top left-hand corner of the screen, you can change repos there as well. The next is it tells you what branch you're on. So by default is master because that's just what default is. Every repo has a master branch. And then this next box up here that says fetch origin is the last time you pulled your changes from your repo. So it's basically like how old your data is. So in this picture, I had last fetched 12 minutes ago, which meant anything that had come into the repo within the last 12 minutes, I won't have on my computer, but anything that's older than 12 minutes, I will have on my computer. And on the left-hand side, we have all of the changes we've made locally to our repository. And since we just cloned the repo, we have no changes. We're all good to go. Okay, so now if we click on the branch drop-down menu, we can create a new branch. So I have this branch that I made called First Changes. And it's just a branch for me to develop my first changes on. Make your name descriptive. Make your branch names as descriptive as possible, just not super long. So First Changes, I will admit, is not a very descriptive name. But I can put on create flow model or create flow model something, whatever I'm creating it for. And that would be a better branch name because we're going to have a lot of branch names, and so we want to make sure they're as descriptive as possible. And so it's really easy to create a branch in GitHub Desktop. Okay, so now we're going to make some changes. You will now have a directory somewhere in your file explorer of this repo. You probably had to set that up at some point during the setup. Make a new text file with your name and go back to your GitHub desktop, and you should see some green on the left-hand side where you made a new file, saying that you made a new file. Okay, so now it's time to write a commit. Remember, a commit is just something saving the changes that we made in a packet of like, these are all the changes I've made. So each commit has a commit message, which I put in this box. Here my commit message is I created abbystar.txt, and my description is it's my first training commit. The description is optional, yet helpful. All you need is the commit message. The commit message should be under 40 characters, but should be descriptive. We just don't want paragraphs in the commit messages, but the descriptions can have as many paragraphs as you want. And once you commit, all of the green should go away because all of your changes are saved in some way in some commit package. Okay, the last step is push. So right now we've made some changes, we've committed it, and all of our changes our commit is still locally on our computer, and we need GitLab to know that we've made this commit. So the next thing you do is you push. There's a button. You push origin, and you select your branch, and you push. Now, when you go to GitLab, you can create a merge request and to merge this into master. In order to find your branch in GitLab, there's a drop-down menu that allows you to select your branch, and when you go to your new branch, there's going to be a create merge request, a button that you can ask to merge your branch into the master branch. All right, that is the end of the presentation. If there are any questions, please ask me now, or if you need to go back to any of the slides to like see something, because I'm not sure if I was going too fast or not, let me know.
You might want to go back to the branch or repo cloning and stuff, because it seems like